Alright, it's time for the math. Easy solution. We're going to discuss linear approximation, basically introduce what it is and do some examples. Basically, linear approximation, let's say if you have a curve like this, this is x, this is y, and you have some sort of curve that's like this, and let's call this one f of x. And then, so basically, linear approximation is near, let's say, a point. If we know the tangent line at this point, let's call this point A. It's point A, and this is basically, well, f of A. This is f of A. So basically, to approximate values close to this, all we got to do is find an equation of the tangent line. So if we were to draw a line like this that's tangent to it. Yeah, so I just made the line a bit better, but basically it's all you gotta do is, if you were to draw the equation of the tangent lines, let's call this one the tangent line or linear approximation L of x. So basically, if we know this equation, then we can determine values close to A. So we can get, we can approximate values close to A. Because as you can see, that the value from, let's say, here and here, if you know this equation, it's similar to this one. It's close to this, but then as it further goes out, this and this are way off. So basically, close to A, you can get approximate values, because sometimes the f of x is very complicated. Sometimes you just want a simple way of solving. Complicated, yeah. So this L of x, basically equation of, it's just equation of a line, but it's a tangent line at A. So you could write the equation as, well, L of x is just equals to mx plus b, because you know my equation of a line, the video I showed, just equation of a line just y equals mx plus b, where there's a slope. So in this case, m would just be f prime of a, so basically the derivative at here, or the slope at a. And then to solve for b, you gotta just, well, we know this point they both share, f of a, so we just put, so at a, or a x equals a or whatnot, so we get f of a is equal to, just a little rearranging, f prime of a times, well, at x is equals a, and then plus b. Just solve for b. Then yeah, rearrange this one. You get b is equal to f of a minus f prime of a times a. Let's plug this inside, and we get just b. We get L of x is equal to f prime of a times x. Then plug this into b, so we get plus f of a minus f of a times a. And then collect the like terms, in this case f prime of a, so we get f prime of a, then this is just going to be x minus a plus f of a. So this is our linear approximation right here. And this is just called linear approximation. And so linear approximation of, it's basically, it's of f of x at a. So it's approximately f of x. Or this is, yeah, so you could just write it as this approximate sign, f of x, near a. So it is basically near a. Always keep that in mind. So now let's look at an example here. So here's example one. This one I got from my calculus book. So let's say, suppose that after you stuff a turkey, its temperature is 50 degrees Fahrenheit, and then you put it in a 325 degrees oven. So then after an hour, the meat thermometer indicates the temperature of turkey is just 93 degrees, so went up from 50 to 93 in an hour. And 8 degrees Fahrenheit. And after 2 hours, it's 129. So basically predict temperature after 3 hours. So we could use linear approximation in this case. Well, you could just, first of all, let's just take a little graph of temperature versus time. Let's just call this T, and then this is hours, and this is temperature. It's called T, capital T, and this is degrees F. So basically, at time 0 is when you first stuff a turkey, it's 50 degrees. Let's just make a scale like 50, 100, 150, And then now, basically, then you put it in a 325 degrees oven. Basically, well, in an hour, after an hour, the turkey is 93 degrees. So let's say after an hour. So this is 93, somewhere around here. Let's call this one's 93. And then after 2 hours, it's at 129. So let's write 2. After is 129, somewhere around here. Or it's actually, yeah, it's somewhere around there. So the curve would actually look something like this. So it looks something like that, and then this is 129. Scales a bit off, but basically, if you want to get at 3, what is it? So basically, we want to know what this is. We predicted. Well, basically, we can, if we were to draw a tangent line here, we could just do linear approximation like before, or just draw a tangent line here. The curve's a bit off, so we'll just draw it like this. A bit off. We'll just so this value, it should be somewhere around there. It's kind of curved like that. We don't know what it is, but we could use linear approximation again. So this one, we'll call this this line L of x, and this one is just T of x. So basically, if we write down the equation, we know that let's say we'll use this point as a frame reference or as A. So we'll go, well, we know that the equation is equal to f prime of A x minus a plus f prime of a. So we use this one right here. We use at t is equal to 2. So in this case, we're going to get L of x is equal to, well, f prime of 2 times x minus 2. So we go at a is equal to 2. So in this case, because it's closest to 3. And then plus f of 2. And then we know that this one here, this is just 129, but we don't know the derivative in this case of f prime of 2. But we can predict it using, let's just use this slope right here. We'll just use the slope between 1 and 2. So then we could say f prime of 2 is roughly, well, we could just go T2 minus T1, temperature of that, and then divided by the hour. So we'll get 2 minus 1. This just equals to 129 minus 93. So we just use the slope from there to there to roughly equal f prime of 2. And just over 1. This one just equals to 36. So then we plug this all in here. So we're going to get L of x is equal to 36 times x minus 2 plus 129. So we have the equation of a line roughly near f prime of 2. F of 2 or at 2 hours. So now to predict the 3, we just put L of 3 is equal to 36 times 3 minus 2 plus 129. This one is just 36. This is just 1. So we're going to get 36 plus 129. 36 plus 129. This one just equals to, well, you could write a 36 here. This is 5, 1 here, 6, 1, 5. So it equals to, L of 3 is equal to 165 degrees Fahrenheit. So it's roughly here, but then from the curve, it's more, from the graph, it's more of a curve down, so it would be a bit less than 165. So this is L3, so it's approximately this, but should be less. Should be less, or a bit less. A bit less in real life, or, yeah. Well, okay, so that's example 1. Let's look at example 2 now. So, example 2, we'll just write it here. Example 2 is, let's just say, find L of x, or the linear approximation of the equation f prime of x is equal to square root x plus 3 at, basically at a is equal to 1. And then use it to approximate, use it to approximate f prime of, f prime of 0.98. And f prime of, let's say, 1.05. So I'll show you, yeah, so basically to get the linear approximation of this one, we know again this is just going to be L of x equal to f prime of a x minus a plus f prime, no, just f of a. So when a is equal to 1, we know that, well, first we got to do derivative of this one, so let's just go over here. So let's just write f of x is equal to x plus 3. And then, well, f of a or f of 1 is just equal to, well, 1 plus 3 is 4. So square root 4 is just equals to 2. So we know that f prime of a is that. And then in this case here, now the derivative of this is just f prime of x using the power rule, the general power rule. This is just going to be 1 over 2. And then it's going to go down here, x plus 3. Because it's going to be 1 over 2, bring the 1 over 2 down. Then minus 1, which is negative 1 over 2. So it brings it down here. And then f prime of 1 is just going to be equal to, well, 1 divided by 2. 1 divided by 2, 1 plus that's 4. So then this is just going to be 1 over 4. This is going to be 2 times 2, so it's 4. Then we plug this all inside. We're going to get linear approximation of it. Is just going to be this one, f prime of 1 is equal to 1 over 4. X minus a plus 2. So we got this one. Now we could use this to approximate, well, 0.98 is basically, yeah, that's where an x is, because we have base 0.98, you're going to get square root of, well, 0.98 plus 3. This is equals to square root 3.98. So there's basically, it's going to be close to 2, and similarly the other one is going to be, well, 4.05. That's this one here. But then all we gotta do is plug in these numbers inside. We're gonna get a rough number to it. Well, actually, this one we can actually rearrange this one to make it simplified further. L of x is equal to, just expand this out. X minus, oh, this is 1. This is 1. Yeah, minus 1 over 4 plus 2. Right, common denominator times 4 plus 4 is 8. This is 8 over 4. And this is going to be 7 over 4. So the simplified linear approximation just equals to 1 over 4x. And this is plus 7 over 4. And now to plug, now if you want to approximate 0.98, this just equals to, well, 0.98 over 4 plus 7 over 4. And yeah, this just equals to 7.98 over 4, so it's a bit less than 2. You could just leave it like this if you're doing a calculus exam or whatnot, but then if you're putting a calculator, this would equal to well, 1.995 and whatnot. So and then similarly for L, 1.05, this just equals to 1.05 over 4 plus 7 over 4, and this just equals to 8.05 over 4. And this, again, this one plug in the calculator, you get 2.0125. Now to see how close these approximations were, we could plug into the calculator, and but first we know that the curve of basically root x plus 3, well, at 0, this one you put negative 3, so it's just going to be like this. This is negative 3. So a square root curve looks something like this. This is, let's call this x, this is y, and the line, the tangent line in this case, our linear approximation, it's at 1, so it's going to be something like this. It's going to be something like, yeah, like this one. So then basically, if this is our L of x, as you see from the graph, and this is f of x, these are going to be overestimates. So then our approximations were overestimates. We could even plug in the calculator and see it, because from this it's always going to be greater than the value there, than the f of x is at 1. We can plug in the calculator. So if we plug into the Google calculator, we get square root 3.98. This just equals to 1.994 and 99 and so on. So we get square root 3.98 is equal to 1.994, etc. And where this one is 1.995. We could also plug that in. We can also do this one as, let's go, I just want to see if this was right, 9.8 divided by 4. Yeah, 1.995, and then similarly this one 8.05 divided by 4 is 2.05. And now if we were to plug in square root 0.5, yeah, 2.124. So we can just write square root 4.05 is equal to, what is that, 2.012, etc. and this one, yeah, 124. So as you can see, it's pretty close, but it's gonna be less than this 125. Well, yeah, so you could use a calculator to do this, but sometimes you're not allowed to, and whatnot. And then also this approximation gives it for a range of values, and sometimes the values that you're approximating is not necessarily as easy as a square root and whatnot. But and also in calculus, you usually don't have a calculator, so you have to do this. Well, anyways, hopefully you learned this linear approximation, and stay tuned for another math easy solution.